We are talking about adding the terms of an infinite geometric sequence, and we've got a formula for that. It turns out that it's basically like the one we just did if n is infinity. If n was infinity, then this part just fell out of the problem. And so if n is infinity, if we're talking about an infinite sequence, we've got this simplified looking formula. One thing that it's important to notice, though, sometimes we don't read the whole box, but you've got to read this because you've got to pick out this piece of information right here. The sum S infinity of the terms of an infinite geometric sequence with first term A1 and common ratio R, where -1 is less than R is less than 1, gives you the following formula. The R value has to be in between -1 and 1, okay? And if that happens, we say it converges, okay? It converges. Another way of writing this is to say the absolute value of R is less than 1. In my mind, I just think about it if R is less than 1. I almost think about a fraction, okay? So converging, if R was equal to 1/2, it converges. That means there's a sum, okay? Diverge is the opposite of converge, and it means that if you added all the infinite terms up, it would just keep getting bigger and bigger and bigger and bigger and bigger. But like the last example that we saw, we added up an infinite number of terms, and we ended up getting a sum of 5, which seemed kind of weird, but that's converge. So if R is equal to 1/2 or 0.2, that would converge. Or -2/3, that would be fine. On the other hand, if you found R was equal to 2, or R was equal to 1.2, or R equals 3/2, something like that, it's got to be less than 1, okay? Or more properly, in between -1 and 1. None of these would converge, so none of these we wouldn't be able to find a sum using this formula. So when we look at example 8, you can see R. Remember, R is just going to be the base of the power. R equals -1/3, and in this example, R equals 0.9. Both of those numbers are in between -1 and 1, so both of those are going to converge. You're going to have a question on your homework that's going to say, does this converge? And so that's what you have to look for. If that R is in between -1 and 1, it's going to converge, yes. Otherwise, you would say no, or it diverges. So we can find the infinite sum using this formula, but we still need to know A1. And A1 is what you would get when you plug in this number right here. So think about it. If you plugged in that number, you're going to have 2/5 times -1/3 to the 1 minus 1. Well, 1 minus 1 is 0, so you're going to have 2/5 times a fraction to the 0 power. But that's going to just cancel out and give you 2/5. So A1 equals 2/5. Great. So we can find this sum of an infinite number of terms is equal to A1, that's 2/5, over 1 minus -1/3, that's R. Got to do a little bit with fractions, and that's fine. Deal with it. We need to get a common denominator on the bottom so that we can add those fractions. I'm going to see 2/5 over 4/3. We're dividing fractions, so we multiply by the reciprocal. That's 2/5 times 3/4. And I can cancel. 2 goes into 4 twice. It's going to give me 3/10. I think it's interesting that you can add up an infinite number of terms, and it adds up to 3/10. Let's look at part B. We've already got R is 0.9, so that tells me it converges. A1 is what you would get when you plug in this 1. So 0.9 to the first. A1 is just 0.9. So I can find the sum of an infinite number of terms here. A1 over 1 minus R, that's 0.9 over 0.1, which is 9. That's your sum. So we would say it converges to 9. Moving on, future value of an annuity. We've got another equation. This one talks about annuities. You've got to know some variables. S stands for future value. You might want to just think about S as the sum. R is the payment. I is interest. And N is the number of periods, or the number of payments, or the number of times they zap you with interest. Example 9. To save money for a new car, Clayton deposited $3,500 at the end of each year for 6 years in an account paying 3% interest, compounded annually. Find the future value of this annuity. So we want to find S. Pretty easy to tell 3% is I. Make sure you change it to a decimal number though. 3%, 3 divided by 100 is 0.03. 3,500 is the payment, R. And how you can tell that is that's the thing that's happening more than once. Specifically, at the end of each year for 6 years, you can tell that that's going to happen 6 times. Notice this says compounded annually for 6 years. That tells you what N is. That's the number of payments. At the end of the year for 6 years, that's going to be 6 times. So we've got everything we need. We just need to plug it all in. The sum, or the future value, is going to equal 3,500 times 1 plus 0.03 to the N, that's 6, minus 1 all over 0.03, and close it. So it just becomes a calculator question. Honestly, when you type this in, I think you should probably put parentheses around that entire top just to be safe. Otherwise, we're just going to plug it all in. So check it out, 3,500. Then open up the brackets and open up the numerator. I'm going to go ahead and call that 1.03. You can do that in your head. To the 6th power minus 1. And I'm going to close the top, close those red ones. And then I'm going to divide by 0.03 and close the brackets. 22,639 and 43 cents. That's the future value. So if you think about it, Clayton had a payment of $3,500 and he made that payment 6 times. So he only really paid $21,000, but his account through the interest grew to $22,639.43.